Mathematics, Edexcel IAL, Mechanics, M1, past paper, May 2023 will be discussed in this video. Okay, so Mechanics, Mathematics M1, past paper, May 2023. The first question based on momentum. You know the law of conservation momentum. You learned in IGCSE. We had to use that idea. And impulse. You know the meaning of impulse. That's based on Newton's second law. That's obtained from Newton's second law. Newton's second law says F equal ma. That is m into a is the acceleration rate of change of velocity, that is v minus u over t. So that is cross multiply ft equal mv minus mu. Okay, so that is change in momentum is equal to ft. Ft has a name that is called impulse and denoted by I. Unit of impulse is unit of momentum, same as momentum, change in momentum, both will have the same unit, which is kilogram meter per second. Okay, also you must know change in momentum, that is impulse, is a vector quantity. How do we know it's a vector quantity? You know here on the left side, F into t is multiplied, they are multiplied, force and time are multiplied. Time is a scalar quantity and force is a vector quantity. When you multiply a vector by a scalar, you will obtain a vector. The direction of this vector will be always along the direction of the resultant force that changed the momentum. Or I can simply say the direction of the change in momentum is always along the direction of the resultant force that changed the momentum. Okay, so during collision, for example, an object A is moving towards right and object B also moving towards right, let it be. This velocity u1, this is velocity u2, this is before collision. u1 must be greater than u2, otherwise the gap will increase. A won't be able to catch up. If A wants to catch up with B, u1 must be greater than u2. Simple condition, right? So during collision, if you consider, during collision, according to Newton's third law, the object A will exert force on object B and object B will exert the same magnitude of force on A. Both forces will have the same magnitude, opposite direction, and they will exist for the same time period. Those are the Newton's third law pair conditions. During Newton's third law, according to Newton's third law, both forces must have the same magnitude. They should act for the same time in opposite direction. So we know that after collision, the B is going to experience a force along its direction of velocity. So certainly the velocity of B will increase after collision. I'm not doing anything related to unit 1, I'm doing a general theory. So after collision, the velocity of B becomes V2, velocity of A becomes, say, in the same direction. It can bounce off also depending on the time. So it can move in the same direction with the velocity V1 after collision. Okay, so certainly I know that velocity of V1, the magnitude of V1 is smaller than magnitude of U1. The reason, during collision, A is experiencing a force opposite to the initial direction of velocity. So whenever an object experiences a force opposite to the direction of motion, certainly it will slow down. Okay, remember those things. So change in momentum of A. So change in momentum of A or impulse on A is equal to force experienced by A into the time duration that A experiences force. Impulse of B is equal to the same magnitude of force it experiences because Newton's third law, and it's going to experience the force for the same time. So both impulse will be the same. Both will have same magnitude of impulse in opposite direction. That means both will have the same magnitude of change in momentum in opposite direction. Okay, what is the direction of impulse, or what is the direction of change in momentum of A? It will be towards left, because I just now told I is equal to Ft equal to mv minus mu. So the direction of change in momentum of a particular object is always along the direction of the resultant force that changed the momentum. So A is experiencing the momentum, A is experiencing force towards left. Therefore, impulse on A is towards left, and the change in direction of motion, or say change in direction of momentum, or change in momentum, sorry, not direction, change in momentum of A is also towards left. So I should write IA is equal to, it must be towards left because A is experiencing force towards left. IA is equal to mv minus mu. That's the general form. But m, the mass, if I say mass of A m1, mass of B m2. So for A, the mass is m1. The final velocity v1 towards right, but it should be towards left. We are taking positive because A is experiencing force towards left. The change in momentum of A must be towards left. I am taking towards left positive. This is towards right. So minus v1. This minus comes here. Again m1 into u1. u1 is also towards right. Also towards right. I am taking towards left positive. So minus u1. So it's going to be m1 u1 minus minus plus minus m1 v1. That is the change in momentum of A. So for B, the change in momentum of B or the impulse of B should be towards right. That is equal to same general format mv minus mu. So m2, the final velocity towards right, v2 minus m2, the initial velocity is towards right, so m2 u2, that also towards right. Okay, we already considered the direction. I told you both will have the same magnitude of impulse, IA equal IB, because both experience same force for the same time. So equate the both, IA equal IB, because both have the same magnitude of impulse or same change in momentum. That is m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Rearrange it. Bring this minus to the left. m1 u1 plus m2 u2 equal, bring it to the right, m1 v1 plus m2 v2. That's all you have related to momentum, and this we call the law of conservation of momentum. So actually law of conservation momentum is not a special law, it's actually a combination of Newton's second law that is gives the Ft equal mv minus mu that we obtain from the Newton's second law, and Newton's third law says both have the same force for the same time period. So when we combined Newton's second law and Newton's third law during collision, we get finally the law of conservation of momentum. That's all related to momentum. Okay, so the first question, a particle A has mass 4 kilogram and particle B has mass 2 kilograms. The particles move towards each other in opposite directions along the same straight line on a smooth horizontal table and collide directly, head-on collision. Yeah. Immediately before collision, the speed of A is 2u meter per second and the speed of B is 3u meter per second. Immediately after collision, the speed of B is 2u meter per second. So better draw a diagram, it will be convenient to answer. So I take the A is moving towards right and B is moving towards left. If you want, you can draw the way. So there is no specific direction, just I am taking. So I take A is moving towards right. So this is A, which has mass 4 kilogram, moving towards right at a speed of 2u, and B is moving towards left, which has mass 2 kilogram at a velocity of 3u. This is before collision, B dot C dot before collision. So after collision, they are saying B is moving immediately after collision. The speed of B is 2u meter per second. The direction of motion of B is reversed by the collision. So I took B is moving towards left. So after collision, it's reversed. So it must be towards right. So that is 2 kilogram. It's reversed, mentioned in the question. So that should be towards right, which is 2u. So immediately after collision, the velocity of A, I don't know whether it's moving in the same direction or they are bouncing off from each other. We don't know anything. I'll take towards right, that also moving at a velocity V1, I'll take it. Its mass is 4 kilogram. Okay, so the question part A of first question, find in terms of U the speed of A immediately after collision. Then state the direction of motion of O immediately after. Both are actually A and B are interconnected. So we have to do together, A and B together we'll do. So when we solve for one, you will get the answer for the second one also. So A and B will get the answer together. So anyway, I'll write separately A. We'll use the law of conservation of momentum. So the law of conservation momentum should be used in a direction. It could be any direction, but before and after the same direction. So I'll use it towards right. So anything towards right, I'll take it positive. So before collision, the mass is 4 kilogram. It's towards right. 4 into 2u. This is towards left. So plus 2 into minus 3u equal to, for this 4 into v1 plus 2 into 2u. Okay, so I used the law of conservation momentum. I use it towards right, positive. So solve it. It's going to be 8u minus 6u equal to 4v1 plus 4u. Solve it. So 8u plus minus 6u, 2u. When it comes to the left side, it will become minus 2u. So when you solve, you will get v1 is equal to minus 0.5u or half u. 0.5u, negative 0.2. So the negative sign shows, so the speed, they are asking A part, speed of speed of A after collision is 0.5u, or you can say half u. No direction, because they are using the word speed. The direction, actually B part, the direction they are asking, I got minus. What do you mean by this minus? I took after collision towards right. I don't know whether it's going to be left or right, I didn't know that, but I just took it same as initial. Initially it was taken towards right, I took it as same as earlier, towards right, but I'm getting negative sign means now A is going to bounce off. That means the direction of A will be opposite to its initial direction of velocity. So after collision, velocity of A, or the direction of velocity of A after collision will be in opposite of A after collision will be in opposite to initial direction. Okay, see part, find in terms of U the magnitude of impulse received by B in collision. State the units of your answer, anyway, kilogram meter per second. Magnitude of impulse received by B, they are asking. If you find it for A or B, you will get the same answer. I told that according to Newton's third law, both will have the same magnitude of impulse, but in opposite direction. So here I had to change it because I took in first part the velocity of A after collision towards right. We found that towards left 0.5 u. So this is going to be 0.5 u. Okay, during collision, if we consider A and B, this is before collision, after collision, during collision, if I consider DC, not necessary to draw, but I'm just for your understanding, I'm doing it. During collision, B will experience force towards right, A will experience force towards left. So that means A will have impulse towards left and B will have impulse towards right. Both will be both will have the same magnitude. So they are asking to find the magnitude of impulse on B, but even if you do it for A, you will get the answer. I'll do them for both separately. One of it is enough. You will get the same answer. Okay, if you are doing it, how to do that? So the C part, for B I'll do first. The question is about impulse B. I know the impulse experienced by B is towards right. So we know that general equation I equal mv minus mu is the general equation. So for B, the impulse is towards right. So I am taking towards right, positive. That's going to be mass of B is 2 kilogram. Final velocity is towards left. I found it now. So I am taking towards right, positive, because B is going to experience impulse towards right. So I took the positive direction. Actually, which direction is going to experience impulse? To the right. I took that towards right, positive. But after collision, for B, it's towards right. Sorry, it's towards right, right? The mass is 2 kilogram. B is experiencing velocity towards right. So 2 into 2u. This minus comes here. Again, the mass is 2 into. Before collision, velocity of B is towards left. Towards right is taken positive. So into minus 3u. Solve it. So it's going to be 2u into 2, 4u, minus minus plus 6u. It's going to be 10u. The answer is 10u. The unit is kilogram meter per second. So I did it for B. Okay, you can ask me, can't you do it for A? You will get the same answer for A if I use it. But not necessary to do both. Since they asked for B, I did it for B. But I told that A and B will have the same magnitude of impulse. You'll see whether A is also getting the same impulse. For A, if I do it, the impulse experienced by A is towards left. So I equal mv minus mu. I'm going to use it towards left. So the mass of A is 4 kilogram. The final velocity is towards left into 0.5 u. This minus sign comes here. Mass is 4 kilogram. Initial velocity of A is towards right. The towards left is taken positive. So into minus 2u. Solve it. 4 into 0.5, that is 2u. Minus into minus plus. 4 into 2, 8u. You will get 10u kilogram meter per second. So both will have the same magnitude of impulse. That's what I told when I did the brief theory revision. Okay, second question. A particle P rests in equilibrium on a smooth horizontal plane. It's based on vectors. A system of three forces F1, F2 and F3 were given. F1, 3CI something given, F2 also given, is applied to P, the particle which is at rest. Given that P remains at equilibrium, find F3 in terms of C. Okay, so actually, you know, vector addition rule. When object is at rest under three coplanar forces, the resultant force must be equal to 0, and resultant of any two must be equal to the third force. Say for example, if there is an object, there is a force this direction F1 acting, F2 is acting this direction at an angle theta. So F2 is acting somewhere here, means F2 is acting this direction at an angle theta. So resultant of these two, how do you find it? Vector diagram, vector force. So vector F1 plus F2, vector addition rule says the vector F1 plus vector F2, the F2 should be drawn parallel to it. We are not going to draw, but I am telling you the theory part, the idea. F2, if I draw along this direction, this is angle theta, this is F2. The resultant is from initial to final. That's the vector addition rule says. This is the resultant. Resultant of these two vectors is along from the initial point to the final point. So this is the resultant vector. So if you want to keep this at balance or equilibrium, you should apply the third force along the same line of action of the resultant in opposite direction. So if you apply the third force, F3 this way, such that its resultant, the resultant of these two is equal to the F3, the magnitude wise, and the line of action of F3 is along the same line of action of resultant of F1 and F2, the system will be at rest. So mathematically, we show this like this. So the resultant of F1 and F2 should have the same magnitude as F3, but the direction of F3 must be opposite, note down, opposite to the resultant of F1 and F2, opposite to the resultant of F1 and F2, right? So here they are saying F1 is given 3ci in terms of vector, that is the in I direction component is 3c, j direction the component is 4c, right? The vector F2 is given as minus 14i plus 7j, right? These are the two forces acting on an object. There is a third force. When it also applied, it's at equilibrium. So the resultant of F1 and F2 must be equal to the magnitude of F3, but the direction of F3 must be opposite to the resultant of F1 and F2. So we'll find the resultant of F1 and F2. If you want, you can simply say like F1 plus F2 in vector addition, F3 equals 0, I can show. Or simply I can find like this, find the resultant of F1 and F2. The magnitude of F3 should be same as that one, but opposite direction. Opposite direction means minus sign. Say for example, if vector A equal vector B, if you want to reverse the vector A, that should be written as minus A. Opposite direction means should be written with minus. So anyway, we can solve by this way, or I can say resultant of F1 and F2. That is also simple, easy to understand. Resultant of F1 and F2, that is resultant vector of F1 and F2, F1 plus F2 vector addition. So F1 is 3ci plus 4cj, F2 minus 14i plus 7j. Okay, solve this one. To find the resultant of F1 and F2, it will become 3c minus 14, yes, 3c minus 14 minus 14 I plus 4c plus 7j. So the magnitude of the third force F3 should be same as this man. If I find the magnitude of, you know how to find the magnitude of R, you know that square root of this one plus this one. Anyway, I am not asking for find it, but magnitude wise it should be the same. So the F3, it should have the direction opposite to the resultant. F3, the resultant of these two should be from this to this. If I name it A, B, C, the resultant of F1 and F2 should be along AC, but that is balanced by the third force, means direction of third force opposite to the direction of resultant of F1 and F2. So F3 should be equal to minus R. So that's going to be multiply this minus, that is minus of 3c minus 14i plus 4c plus 7 4c plus 7j. So that's going to be finally the F3, the vector force is going to be minus 14 minus 3c I minus, when it goes here, minus 4c plus 7j. That is the force F3. Okay, we found the resultant already. I'll erase it. We need that. I wrote it there. Okay, so the B part says that given that see now, sorry, the force F3 is removed from the system. So removed from the system, I already explained resultant of F1 F2 is equal to F3, opposite direction, right? Anyway, So given that C is equal to 2, find the size and angle between the direction of I and direction of the resultant force on P. So find the size of the angle between the direction of I and the direction of resultant force acting on P. So size of the angle. Okay, so we need to find the resultant force. We got the general equation in terms of C. So when C equal to, the resultant vector of F1 and F2 will be 3 into 2 minus 14 I plus 4 into 2 plus 7 J. So it's going to be minus, yeah, solve this and you get it. It will be minus 8I plus 15J. So minus 8I plus 15J, that means the horizontal component is 8 to the left minus I. So 8 minus I can say this, minus 8I could be written as 8 minus I, like this, 8 minus I. So it's towards left, this is towards up. So the resultant if I want to find, so the resultant, this direction, this is 8, upward direction, 15. So the resultant will be somewhere here. This is the resultant. We need to find this angle theta. Okay, so simple. Think about vector triangle. So this is 8. Again, I am drawing a vector triangle. This is 8. From here, this is 15. The given vectors should follow each other. This is 15. The resultant this way. We need to find this angle. Is it? We have to find that angle. So the question is find the I. Sorry, they asked to find the angle with I. So we need to find this angle. This angle we need to find theta. So the question says, yeah, find the size and angle between the direction of I. Direction of I is already mentioned in the question. In this question, I and J are horizontal perpendicular vectors. So I is always taken this way. So from this I direction, from this I, this is the I direction, from this I we need to find the resultant means theta. So we'll find the alpha, tan alpha is equal to 15 over 8. From this alpha you will get 62 degree, 61.9, so 62. So theta is the question. From I we need to find the direction of resultant. So theta is going to be 180 minus 62. So that will be 118. That's the final answer. Okay, that's the final answer. Okay, so C part, mass P is m kilogram. Given that the magnitude of acceleration is 8.5 meter per second squared, find the value of m. So we need to find the resultant force of this. So x component to the left is 8, upwards or towards y direction is 15. So we are going to use finally F equal ma. So we need to find the resultant force. So C part. So we'll find the magnitude of the force. F is equal to square root of 8 squared minus 8 squared or 8 squared is not a problem because it will become positive, plus 15 squared, this much of Newton. So solve it. The resultant force you will get 17 Newton. F equal ma, Newton's second law. F is 17. The mass is the question. The acceleration is 8.5. So mass will be 2 kilogram. Okay. Okay, third question. Two students observe a book of mass 2 kilogram fall vertically from rest from a shelf that is 1.5 meter above the floor. Student A suggests that the book is modeled as particle falling freely under gravity. Use students A's model to find the time. So it's actually a very basic thing. S equal ut plus half at squared. You can use it. So that's equations of motion. Downward we'll use S equal ut plus half at squared. So S is 1.5 meters. It's released from rest. plus half into 9.8 t square. Solve it and find the t. You will get 0.553 seconds. That's right. Student B suggests an improved model where the book is modeled as particle experiencing a constant resistance to motion of magnitude r. So there's a constant resistive force which is r. Given that the time taken for the book to reach the flow is 0.6 seconds. So here we are getting 0.553, but if you model it for one decimal point it will be 0.6, but anyway they are giving 0.6 when there is drag force or resistive force. But here we don't consider the resistive force. We assume A is 9.8 means we don't consider resistive. That is actual 9.81 actually, but for in mechanics we are using 9.8. And we don't consider any resistive force in this one, because the only force acting on the object, we take it the weight. Say for example, if there's an object, the only force acting on it is the weight, means mg. If you use F equal ma to find the acceleration, here I put A, which is 9.8, that's a gravitational acceleration. If there is only one force, that is the weight, no drag force, the resultant force also mg equal ma, m get cancelled, g equal a. So that is acceleration is equal to g, which is 9.8. 9.81, but in mechanics we take 9.8 meter per second square. So here I took 9.8 means I assume there is no drag force. Then I found the time as 0.553. But as a student says, there could be drag force which is constant and which is r. Okay, and the time is given. Use student B's model to find the value of r. So the only difference is there is a drag force or resistive force r is acting. When I use F equal ma, I can't just put mg, because the resultant force, this F is always, I call Newton's second law, F is the resultant force, careful, not one force, resultant force in a particular direction. We consider the downward direction, so the resultant force downward is mg minus r equal to ma, right? We need to proceed further, but this is the way we have to use. So when you do this way, you can see, earlier I got acceleration is equal to gravitational acceleration. Here I will get an acceleration lower than the gravitational acceleration, because divide by m to make a subject, mg minus r over m. This I can write mg over m, that is g minus r over m. You can see this factor is subtracted from g. The acceleration is going to be smaller than g because you are subtracting a quantity which is r over m. So when there is drag force, certainly the acceleration will be less than 9.81. So here they are giving that the time taken is 0.6 seconds. So this is part of the answer. So I'll do the B part separately here. I'll use the same diagram. So I'm going to write the same thing again. F equal ma downwards, that is mg minus r equal ma. So if I make a subject, a equal mg minus r over m, that will be g minus r over m, right? Then I need to find they are saying the time taken is 0.6 seconds. So I can use s equal ut plus half at square again, but there for a I can't put 9.8, but I have to substitute this one. So I'm going to use downwards s equal ut plus half at square when there is drag force. The height is going to fall down is the same 1.5. Initially it was at rest, half. Earlier I put 9.8, I already explained, because there is no drag force, but there is drag force, so acceleration will be g minus r over m times t squared. T squared is given 0.6 squared. So I'll raise this part. Okay, we know everything. So cross multiply 3 equal g is 9.8 minus r. I need to find the mass of the object is the book is given 0.2 times 0.6 squared, 0.36. Okay, solve it. You know how to solve it. Divide 3 by this one and make R subject. You know the solution is not an issue. So when you solve, you will get R is equal to 0.293 Newton. That's the resistive force, drag force or resistive force, which is constant. Okay, question number 4, based on moments condition for equilibrium. The diagram is given. Figure 1 shows a beam AB of mass m kilogram, length 2 meters, suspended by 2 light vertical ropes. The ropes are attached to the points C and D. So at C and D, the ropes are attached. On the beam, where AC 0.6 meter and DB 0.2 meter. The beam is in equilibrium, so resultant force is equal to 0. When object is at equilibrium, two conditions must be satisfied. First, when you resolve all the forces to any direction, whether vertically or horizontally or at an angle theta, if you resolve all the forces to that direction, the resultant force must be 0. Second one, when you take moment, you know, in IGCSE you learn year 10, moment means force into perpendicular distance to the line of action of force from a point. So that is moment. If you find the total moment for the system of forces acting on the object about any point, this must be equal to 0. Total moment equal to 0, we can say, or the total clockwise moment must be equal to total anti-clockwise moment about any point. Even how to take moment I don't need to tell, because even year 10 you learned in physics. Okay, so particle of mass p kilogram is attached to the beam at A, and the beam remains in equilibrium in horizontal position. So there's a particle piece attached at they are saying attached at A, the p kilogram. So this is going to be P, the force is p kilogram, they are saying. PM kilograms or PM kilograms, so that is PMG. PM kilogram, so force means kilogram into gravity G, so PMG is the force acting at A, PMG, PM into G, right? Okay, the beam is modeled as a uniform rod. The meaning of uniform rod is the weight of the rod, that is given the mass of the rod is m kilogram. So the weight of the rod mg will act exactly at the center of the rod. So that means from A it will act at 1 meter mg, 1 meter. Right. Given that the tension in the rope attached at C is 4 times of the tension in rope attached at D. So if I say this is tension T, this is going to be 40. That's all the data given. Right. First part, the given that the tension in the rope, 4 times. Use the model to find the exact value of P. Sorry, we had to find the P first part. We had to find the P. Okay. So I told that the system is at equilibrium, 2 conditions. I already told that resultant force in any direction must be 0 and moment about any point must be 0. Now beyond that, we need to use techniques, not physics, techniques to solve with less number of equations. We can solve anyway, but you know, to reduce the complexity, we can use certain techniques. So I need to find first part the value of P, right? We have to find the value of P. So if I want to reduce the unknowns in my equation, first I need to find the T in terms of M, because P is an unknown. If I use upward direction 40 plus T is equal to, then it will become downward direction PM plus mg, unmodeled. Again there will be P. So to reduce the unknowns, I take moment about A first. First I am going to take moment about A. So I can get the value of T in terms of M. So when we take moment about A, we can take either clockwise or anti-clockwise positive. No reason, I'll take anti-clockwise positive. Moment about A, I am taking A part. So that is then moment of P, the particle PMG won't come in my equation, because it is attached at A, the perpendicular distance to line of action of this PMG from A is 0. So that won't come in my equation. That's the advantage. I can eliminate in my equation the unknown P. So if I take moment about A, so that's going to be 40 into 0.6. This is clockwise, so minus mg into 1, the distance 1, plus t into this distance. This is 2 meters, so this is 0.2 means 1.8 equal to 0. Solve it. So when you solve, you'll get this is 2.4 t. This is plus 1.8 t is equal to mg. So you'll get t in terms of mg. It will be mg over 4.2. Right. Or you can say simply this is as t is for mg of 4.2, then 40, that will be 4 mg over 4.2. Right. Now I need to find the P. Now I will take the second condition. Resultant force in any direction must be 0. That is, resultant force in vertical direction must be 0. Means when I consider upward direction, T plus 4T must be equal to total downward force. Must be equal to total downward force. That is PMG plus mg. Now for t, you can substitute mg over 4.2, 4 mg over 4.2 equal, all them anyway is going to get cancelled. So that will become, so bring the mg to the left, this mg to the left, minus mg equal PMG. So anyway, so this is 4 mg plus mg 5 mg, 4.2 if you take common, it's going to be 4. So it's going to be 0.8 mg over 4 mg, 4.2 equal PMG. So mg will get cancelled. P is going to be 0.8 over 4.2, that we can write in given in fraction as 4 over 21, or in decimal points 0.19. That's the value of P. Okay, so B part. The particle of mass pm kilogram at A is removed and replaced by a particle of mass qm kilogram. Okay, now they are replacing the pm kilogram by qm kilogram. Right, what is happening when it is replaced qm kilogram? So the force will be qmg at A. The beam remains in equilibrium, so it's not toppling, it's remaining in equilibrium in horizontal position, still horizontal, but it's now on the point of tilting. Now it's on the point of tilting, means it's still horizontal, but little bit it has left away from the D. So that means it's going to tilt. About of tilting means slightly it has gone up, but still horizontal, means this tension will become equal to 0. It's going to slightly, still horizontal, slightly tilting. So this string will slack, it will become 0. So earlier this was T and this was 40. Now it's going to be a new tension T1. The question is, using the model to find the value of Q. Right, okay, so still it's in horizontal position, but its point of tilting means slightly it's going to tilt, right? So the rope attached to the D will slightly, it's going to sag, so tension will become 0. So that's a big part. So still it's equilibrium, still horizontal, but only thing it has slightly tilting, so tension becomes 0. Here the tension is T1, right? So condition, the theory is the same. Resultant force any direction must be equal to 0, moment about any point 0. So again we need to find the Q. Same approach, I want to eliminate Q in my equation. So I'm taking moment about A first. So B part, I'll take moment about A in anti-clockwise direction. So this is 0. So T1 into 0.6. This is minus, this is the only force in clockwise way, minus mg into 1 equal to 0. So T1 will be equal to mg over 0.6, or up and down multiply by 10. So 10 mg over 6, that is 5 mg over 3. That is T1. Now I told the same condition, the resultant force must be 0 in any direction. So if I consider upward direction, this is the only force T1, the downward force QMG minus QMG minus mg equals 0. So take the QMG as a subject, equal T1 is 5 mg by 3 minus mg. mg will get cancelled, so Q is going to be 5 by 3 minus 1, that is 2 by 3, or 0.26 and 0.67, but in Q equal 2 by 3. That's the final answer. Part C. State how you have used the modeling assumption that the beam is uniform. That means we assume the weight of the beam is acting at the center of the beam. Question number 5. This graph is given. So it's a speed time graph. Any question based on speed time graph, we should know the properties of the speed time graph. Gradient gives the acceleration, and the area covered by the graph and the time axis, or simply we can say area under the graph gives the distance for speed time graph. For velocity time graph, area under the graph gives the displacement. So the speed time graph in figure 2 illustrates the motion of a car traveling along a horizontal straight road. At time t equals 0, the car starts from rest and accelerates uniformly for 30 seconds. So uniform, you can see the gradient is constant, so acceleration is constant, and this value is given as v. Okay. Accelerates uniformly for 30 seconds until it reaches a speed of v meter per second. The car then travels at constant speed v meter per second until time t equal t, capital T seconds. So the area covered by this trapezium gives the distance traveled by the car during the time, capital T. Show that the distance traveled by the car between t equals 0 and t equal capital T is v. They also show that vt minus e. Okay, that's nothing. Find the area under the graph. So that gives the distance. So A part, area under the graph. So the distance is equal to area under the graph, or area. It's a trapezium. So half into addition of the parallel side. So this is length. Length means is a time actually. So in terms of, because the area gives the distance, because the time, the speed, area, to find what could be the unit of area, y into x, the unit of y into unit of x. Unit of y is meter per second, unit of x-axis is seconds s, so you will get meter. So that's a distance. That's a basic way you can check what will be the quantity when we find the area, right? So this length indicates that length means not meters, it's time. The quantity, the length, this side indicates capital T. Parallel side we have to add it. Then this length is, this is T, this is 30 means this will be T minus 30 into the perpendicular distance between the two parallel side, that is V. So it's going to be half into T plus T 2T minus 30 into V. So that means multiply by half, that means it will become half into t, that is t minus 15 v. So they asked to show this one e into t minus 15 or t minus 15 into v, same. So this is the answer they asked to show. They put the v in front, doesn't matter, it's not an issue. A into b is equal to b into a, so I can say this v. Okay. That's the answer they asked to show that, right? That's nothing. A motorbike also, so I'm going to the second part. A motorbike also travels along the same road. The motorbike starts from rest at time t equal 10 seconds. So the motorbike is starting 10 seconds later and accelerates uniformly for 40 seconds. So it's accelerating uniformly for 40 seconds. It's starting at time t equal 10 seconds. So 10 seconds later, because the time is starting 0 when the car starts its motion. So it's starting 10 seconds later. Then it's accelerating for 40 seconds, means at t equal 50 seconds, is it? At time t, because t is starting 0 when the car starts. So when the time becomes 50 seconds, the car stops accelerating. So it's accelerating for 40 seconds, they are saying. So then they are saying the acceleration of the motorbike is the same as the acceleration of the car. So both will have the same acceleration. Means the motorbike is starting 10 seconds later. So here it should be 10. I am not drawing according to the scale, but just I am drawing. So this is 10 seconds if I say. The motorbike is accelerating from 10 to 50. So because 40 seconds is accelerating, so 50 somewhere here. Until that it's accelerating. But they are saying the acceleration is the same. Acceleration of the car and the acceleration of the motorbike both are same, means they should have the same gradient. They should be parallel lines. Same gradient means the lines should be parallel. So from 10 to 50, so I'll just put 50 here. 10 to 50, the line should be parallel. So somewhere here, it's a parallel line, eye level. So it's going up to 50 seconds. This is 50. So both lines are parallel. So both have the same accelerations. They must be parallel lines. The motorbike then travels at constant speed for further 10 seconds. Means here further 10 seconds means 50 to 60. 50 to 60 is traveling at constant speed. Constant speed. Right. Before decelerating uniformly until it reaches the speed of v at time t seconds. So again, it's decelerating. So it's moving at constant speed and then it's decelerating until the speed becomes the same as the speed of the car at time t seconds. So this time its speed becomes v. So it's going to decelerate uniformly. Right. This is the blue color graph is for the car and the black color graph is for the blue color graph is for the motorbike and the black color for the car. Blue color for the motorbike, the black color for the car. Motorbike acceleration and the acceleration of the car both are same. The question says so the lines should be parallel. This black color line and this blue color line are parallel lines because they have the same gradient, same acceleration. Okay, so B part. On figure 2, sketch speed time graph for the motion of the motorbike. So I already drew it, right? So that's over. Then C part, show that the constant speed of motorbike is 4v by 3 meter per second. At time t equal t seconds, the distance traveled by each vehicle is the same. That is for the next part, D part. But here show that the constant speed of the motorbike is 4v by 3. So 4v by 3, the constant speed of the motorbike. So this is the constant speed. So we'll take that speed, constant speed v1. So we need to show that v1 is equal to 4v by 3. Okay, so nothing. We have only one information, the relationship with v and v1 both have the same gradient. Is it both have the same gradient? We'll use that idea. Okay, we'll use it for the car. The acceleration for the car, the acceleration is equal to the gradient v minus 0 over 30 minus 0. So that's going to be v over 30. But for the motorbike, The acceleration is the same for the motorbike. The acceleration is the same. A is equal to its acceleration v1 minus 30. V1 minus 0, the gradient v1 minus 0 over 50 minus 10. Find the gradient of this blue color line. V1 minus, here the y value is 0. V1 minus 0 over x value 50 minus 10. Same acceleration. So that acceleration is the same as this one, car, v over 30. So that is v1 over 50 minus 10, 40 equal to v over 30. So 30, 40, zeros will get cancelled. You can multiply the whole equation by 10. So v1 is going to be, make the v1 subject 4v by 3. That's the thing they asked to show. We got it. Okay, so now the part D, before that they are saying, at time t equal capital T seconds, the distance traveled by each vehicle is the same. So both have traveled, the motorbike and the car both have traveled the same distance during time capital T. That means the area under the black color graph, that indicates that graph is drawn for car. The area under this black color graph and the area under the blue color graph. Blue color graph is for motorbike. Both should have the same area, right? Now you can see, now that means actually there's only one property we are going to use now. Area has to be equated. We should equate the both areas. Then we'll get the value of time. Okay, so it's like a technique, nothing. So what I thought is, when we consider the area under the black color graph, that is a trapezium, this area, you can see this area is common for both graphs. So that area is common for both graphs, means if I shade it, the common area, this is the common area. You can see this is the common area for both graphs. So it's a common area for both. So that means the area under the black color graph when we consider, and the area under the blue color graph when we consider, this red color, the shaded area is common for both. Both area should be the same. Area under the black color graph and area under the blue color graph must be same, means because they have the same distance they travel. Means if I don't consider this shaded area, the area of this portion is a parallelogram. This area, the parallelogram, this area, with that if I add this red color area, I will get the area for the car. That's the distance traveled by the car. Same way, if I add area with red color, the area of this trapezium, I will get the distance traveled by the motorbike. So since the red color area is the common area for both, these two areas should have the same magnitude. That means the area of this parallelogram, area of this parallelogram, the green color what I use, area of this parallelogram and area of this trapezium should have the same magnitude. So by equating them, I can get the value for capital. If you want, you can find the area of the trapezium black color, area of the blue color. Anyway, you can do that because already we have found the area of the black color trapezium. So only thing you need to find the area of the blue color. You can do that way, but I want to do like, I want to equate the area of the parallelogram and the area of the trapezium what I drew by green color dot and the green color stripe. I want to equate it. So in that situation, I need to find the value of this time where both have the same speed. This time I need to find it. Let that time be t1. Okay, finding that time t1 is not a big issue. So because we know that's a gradient of this line. So that is the gradient of the motorbike when I consider this blue color line, v minus 0 over t1 minus 10. That line, green color, the blue color line, its gradient, we already know that V over 30 is equal to V over 30. So that means V over T1 equal T1 minus 10 equal V over 30. V and V get cancelled. So you will get T1 is equal to, solve it, cross multiply and solve it, T1 is equal to 40 seconds. So this value is 40 seconds. Okay. Now find the area of the parallelogram. Area of the parallelogram is base into vertical perpendicular height between the opposite sides. So base is this length, that is 10. Perpendicular height, or the height between the opposite parallel sides, that is V, right? So the area of the, I'm going to find the area of the parallelogram. I'm going to equate the area of the parallelogram and the area of this trapezium, right? So area of the parallelogram, that is area of parallelogram, that is base is 10, this length 10 into vertical height V, 10V. Area of this trapezium, the upper trapezium, the small trapezium, because I want to equate both. The length of this length is T minus T1, that is T minus half into addition of the parallel side. So half into addition of the parallel side. So this length is T minus T1. T1 is 40, T minus 40. This length is 60 minus 50, that is 10 plus 10 into vertical height. This vertical height from here to here, the vertical height from here to here, V1 minus V. But we already derived V1, we got the expression for V1, we got V1 is equal to 4 by 3V, we already showed it. So now solve this. So this is going to be half, that is T minus 30, V1 minus V. So V1 minus V, that is V1 is equal to 4 by 3 V. So that is 4 by 3 V minus V. Now this area is equal to 10V. We are equal because area of the parallelogram is equal to area of the trapezium, because I am not considering the red color common area because it's common for both. Okay, so substitute, solve them. Now you will get this one. 10V is equal to, this is 3 by 4V minus 3V, that is P by, so I'll solve that first. T half into T minus 30 times, that is V by 3. That is equal to 10V. So I'll continue here. 10V is equal to half T minus 30 P by 3. V and V will get cancelled. So V and V will get cancelled. So you will get cross multiply 20 is equal to V and V get cancelled. 20 is equal. Now this is 20. That is 20 into 3 is 60. 60 is equal to T minus 30. Solve T 90 seconds. So that sums 90 seconds. So anyway, if you want, you can find the area of the blue color area under the blue color graph, but it's actually, you have to find different areas because it's not a proper shape, we don't have any equation, so you have to find a different way. So that's the reason I thought it's better to find the area of the parallelogram and the area of this small trapezium. Anyway, you can do the other way also, you will get the answer. Okay, question number 6, it's based on friction, limiting friction and condition for equilibrium. You know that condition for equilibrium means the resultant force in any direction must be equal to 0 and the moment must be equal to 0 about any point. The total moment must be equal to 0 about any point. So normally we use the moment when the objects or the objects have well defined dimensions and the forces are acting at different point of action, we mostly use the moments, the principle of moments in those type of questions. But if the object is considered as a tiny point object or particle, we don't need to find the, or we don't need to use the moments because all the forces might meet at one point. Okay, so what's the friction and limiting friction? Say for example, on a rough surface, an object is kept on it, object of mass m is kept on it. So if the object has mass m and if the surface is horizontal, it's at rest means the forces acting on it, the weight and normal reaction. So weight is acting vertically down, mg. If the mass of the object is capital M, so the weight will be mg. There will be normal reaction vertically upwards, that is given by R. So since the object is at rest in vertical direction, it's at rest. So R is equal to mg, because in vertical direction there is no resultant force. R equal mg. The normal reaction could change depending on the orientation of the slope on which the object is kept. Say for example, if the object is kept on a slope something like this, the object is kept on a slope like this where the angle is alpha. If the object is kept on a slope and if the object is at rest, in that situation, the weight is acting vertically downwards, that is mg. If the mass of the object is m, this is the weight acting this way. Normal reaction always act perpendicular to the contact surface. It's what we call normal contact force. So the normal reaction acts always perpendicular to the contact force, that will be R this way. So the object is at rest means here the R won't be equal to mg. Here R equal mg when we consider vertically the line which is perpendicular to the contact surface. In that direction there is no resultant force, so R equal mg. But when we consider here also the object is at rest, if I say, there, when I consider the normal reaction, so along this line if I resolve all the forces, this is perpendicular line which is perpendicular to the contact surface. So this is 90 degree. So this is alpha means this is 90, this is 90 minus alpha, though this angle will be alpha. So when I consider along this line, that is along the red line, there is no resultant force because object is at rest and object is not moving in that direction. So along this direction when I consider, that is which is perpendicular to the slope, the line which is perpendicular to the slope, along that direction when I consider, there is no motion, no acceleration, the object is at rest. In that direction also no motion. So resultant force in that direction must be 0. R minus, we solve this force along this line. I told this angle with that line, the line of action of the vertical weight is alpha. So R minus mg cos alpha equal to 0. So R equal mg cos alpha. So in this situation, the normal reaction is not equal to mg as here. Here it is mg. So remember that the normal reaction also varies depending on the orientation of the contact surface or common surface. Not only that, the normal reaction could vary depending on the forces acting on the object, the additional forces or additional weights acting on the object. Say for example, imagine on this surface, on above this box, this mass of the object is capital M. We are keeping another box which has mass m1. That object has mass m1 we kept on it. Okay, so when we consider the normal reaction now after we keep another box on the previous box which has mass m, now the mass is m. When we consider in this direction, the total force, the weight of this object is acting on this object. So this box will exert a push on the previous box. So when we think about the free body force diagrams, in a little too much we normally teach in physics, but better for to know that if I name the new box P and the previous box Q, if I draw the forces acting on P and Q separately, this is Q, this is P. The weight of the Q is acting downwards, that is mg. Weight of the P is acting on P, that is m1g. With the flow, this is the flow, with the flow or table, whatever it is, only Q is in contact, not P. P is in contact with Q, but Q is in contact with the flow. So the normal reaction we are going to consider between the flow and the Q, object Q, the box Q, right? Okay, these are the two weights. Now what's going to happen? The P is at rest, it's not in motion. Why it's at rest? In vertical direction, this weight is acting downward, so this will have intention of moving down, but it can't move because this will exert a force on Q. It will push the Q downward direction. That's called contact force with a force R1. It will exert a force, the P will exert a force on Q downwards R1. According to Newton's third law, Q will exert the same R1 on P upward direction. Right, now see. So these two are called in physics Newton's third law pair. Anyway, it's mechanics, you call maths, but it's all based on physics principles. Okay, so the P is exerting force on Q downwards. It's a contact force which is R1. So Q will exert the same magnitude force on P which is R1 because Newton's third law. Now look at the P. P is at rest. The P is at rest. I told them it's kept on M and it's at rest. So P is at rest means R1 minus M1G must be equal to 0. So R1 is equal to M1G. Right, P is at rest. That problem solved. Now the force exerted by P on Q is equal to R1. I told that R1 is equal to M1G. This is equal to M1G. Now Q is at rest on the flow. Q is at rest on the flow. So what's happening? Q will have intention of falling down, but it can't fall because it's on the flow, hard flow, okay, rigid flow. So Q will exert a force on the flow downwards. If I draw the flow here, Q will exert a flow on the flow, a contact force R downwards, So the flow will exert the same force on Q upward direction on the same line, that is capital R upward direction. Okay, now this R is the contact force between Q and the flow. I hope you understood, because the Q is at rest, so the Q will exert a force on the flow R. According to Newton's third law, the flow will exert the same magnitude of force on Q upward direction. Now, how many forces are acting on the Q? There are three forces. R1, which is exerted by P on Q, mg, that is the weight of Q, and capital R is the force exerted by flow on the Q. There are three forces acting on Q, and Q is at rest. Now, since Q is at rest, when you consider vertical direction, it's at rest, so vertical direction, resultant force must be 0. So if I consider vertical direction, this is R, downwards mg, this is downwards R1 equals 0, but R1 is equal to M1G, so R minus mg minus M1G equals 0. From this I can say R, that is the contact force between Q and the flow, that becomes, take a minus mg minus M1G to the right, that is going to be mg plus M1G, that we write M plus M, we add the mass and say that is M plus M1G. See, how you can see the contact force between the box Q and the flow has increased. Earlier, when only the Q was there, the contact force, the normal reaction was capital Mg. Now it has become M plus M1G. So the contact force changes. Contact force also could change depending on the objects kept over and over above them, or depending on the slope, or whether you are keeping the object on a horizontal flow or on a slope. Like that, the R also can change. Also, we can change the R by applying additional force. Anyway, this weight is an additional force, but additional force, by applying it also, you can change the contact force, the normal reaction. That based on that idea is used in this question 6. I'll explain that also now. Okay, we'll analyze again how the normal reaction between contact surface changes with extra force acting on the object. Already I told certain examples. Now one more example. And imagine an object, small object or particles kept on floor. Its mass is m, means the weight will act downwards, which is mg. The normal reaction will act, that's a contact force R. So I told that object is at rest, means R must be equal to mg. Right. Now you are applying a force on this object, this direction. You are applying a force on this object, this direction. A force, this direction, F is applied at an angle alpha. Even when you apply the force at an angle alpha, the object is at rest. The object is at rest. Take that way. I am not talking about frictions now. I am explaining how R, the normal reaction between the contact surfaces, varies depending on the external force, right? That's the aim of this small revision, right? So you are applying a force F at an angle alpha. The object is still at rest. So I am not considering horizontal direction, because for that I need to consider frictions. I'll come to that point. But I am considering the equilibrium in vertical direction. In vertical direction, how the equilibrium depends on R. Okay, since the object is at rest, earlier I told before you apply F, R equal mg. Now after you apply F, when I consider vertical direction, how many forces are acting? R plus F sine alpha minus mg. These are the three forces acting on the object, equal to 0. So R is going to be mg minus F sine alpha. So earlier, before you apply this force F, R was equal to mg. I told that. Is it? Only two forces were acting, just the object is kept on the floor. So R was equal to mg. Now after you apply this force F, you can see the normal reaction is decreasing. You are going to subtract this quantity. F sine alpha is subtracted from mg. Earlier, initially R was equal to mg. Now you are subtracting this quantity, means the normal reaction is decreasing. You can reduce the normal reaction also. Right. Now think a situation where the same object mg is kept on the same floor. So the normal reaction now R, the weight is mg down, acting on the object. You are applying a force in this direction at an angle alpha. What will happen now? It's at rest. So R minus mg minus, resolve it, minus F sine alpha equal to 0. So R is going to be mg plus F sine alpha. If you apply the force this way, R equal to mg minus F sine alpha. If you keep the object just on the floor, no other forces acting on it, so there mg is weight, normal reaction is R. In that situation, R equal mg. See, the normal reaction depends on the external force also. Okay, the normal reaction depends on the external force also. Also, it depends on the orientation of the contact surface. I already explained that. Okay, we know this idea. We need these ideas to answer this question. I'll come to the idea related to friction and limiting friction. But you must know the normal reaction also could be changed by using external force. Here the normal reaction will be more than mg, because you are adding a quantity, you are adding a particular quantity. There you are reducing, subtracting a quantity. Okay, so next thing is about friction and limiting friction. Imagine on a rough surface a box is kept. So there will be weight mg and normal reaction R acting. Okay, so rough surface. On a rough surface you have kept a box and you are applying a force this direction. A force F is applied. So when force is applied, the box is remaining at rest, means if I draw the forces acting on the box, we call free body force diagram. So the weight is acting vertically down, mg. The normal reaction is R upwards. The force we are applying this way F. Still the object is at rest. So anyway, in vertical direction, when I consider this is a horizontal force, we are applying parallel to the floor. Horizontal force has no vertical component. So this F has no component in vertical direction. So R equal mg. Anyway, we don't need this now. We consider the horizontal forces. So horizontally, when you apply a force, if the box is still at rest, means there must be a friction Fr that is equal to F. Imagine if you are applying 5 Newton, still it's at rest, means Fr equal to Fr also equal to 5 Newton. You are applying F that is equal to 5 Newton because it's at rest. The behavior is you increase the force to 6 Newton now. When you increase the force to 6 Newton still at rest, means the friction will become 6. Automatically in its own it will increase to 6. Now you are increasing it to 7. Still it's at rest. So friction also will increase to 7. You are increasing it to 8. Still it's at rest. So the friction also will become 8. Now can this friction, can it increase forever? No, it can't increase continuously. There is a upper limiting value. It can't go beyond that value. That limiting friction, the upper limiting, highest limiting friction, we call F limiting or Fr max. Some books they use. That is equal to mu times R, where mu is called coefficient of friction. Mu depends on the type of the contact surfaces between the two objects. So the common surface, how the contact surface, that depends on that property, how much it's smooth, what type of materials. So many factors, they decide the value of mu. We don't say mu for one object, it's a mu for the contact surface. So mu between two objects, the contact surface always remain constant. R, I already told you can vary the R, as I explained earlier in this question. Before starting this question, I explained briefly how R varies. Yes, if you vary the R, this will remain constant. This is depending on the type of two contact surfaces. So if you are not changing the contact surface type, so mu will remain constant, but R could be varied by applying external force at an angle, as I explained earlier, or by keeping another object on top of it, or something like that. You can vary the R. So friction, the maximum limiting friction, is also not constant. It is constant only when R remains constant. Mu is, we take it as constant for a common surface, contact surface. Okay, so by varying the R, also we can vary the limiting friction. So the limiting friction means, for example, the limiting friction is, for example, 12 Newton. So until you apply a force of 12 Newton here, the object will at rest because the friction will continuously increase. But if you apply a force which is slightly more than 12 Newton, maybe 12.2 Newton, then the friction will remain at 12. It can't go beyond it. Actually, when it starts move, the dynamic friction is slightly lower than the static maximum friction. But we normally take both as same. So I can say when the force you apply becomes 12.2 Newton, the limiting friction is 12. So it can't apply a friction more than 12. So there will be a resultant force this direction, 12.2 minus 12, 0.2 Newton. The object will accelerate. So this is the maximum friction between the two given contact surfaces. Or if it varies for the same contact surface, when R varies, as I told earlier, the limiting friction will vary. Careful, in this question, question number 6, we are changing the R also because the force P is changing, right? By changing the R also, we can change the limiting friction for a same common contact surface. Remember that. Okay, so the friction can't increase beyond the limiting friction, right? Okay, so I several times told that limiting friction depends on mu and R. Mu is depends on the type of the contact surface. R should remain constant. If R also remain constant, limiting friction will be the same, will remain constant for the given object and the contact surface. But if R also changes, limiting friction also will change even when the contact surface remains the same. So if you apply a force, so I told this is limiting friction is 12. So if you apply a force less than this force, if you apply a force, the horizontal force that you are applying to move the object, if that force is less than the limiting friction, object will remain at rest. If you apply a force of 10 Newton, the friction will be 10 Newton, which is smaller than the limiting friction, so it will be 10, it will be at rest. When you apply force more than the limiting only, the object will move. Okay. So condition normally, if object wants to remain at rest, what is the maximum force that you can apply? Means maximum force we can say 12, not 11.999, we can say 12. You can't apply more than 12 if you want to keep the object at rest. So the force that you apply must be smaller than the limiting function. I hope you understood the theory. Now we'll go to the question, nothing the question. So question number 6. This diagram is given. A particle of weight W newtons lies at rest on a rough horizontal surface as shown in figure 3. This is the diagram given figure 3. A force of magnitude P Newton, capital N for Newton, P Newton is applied to the particle. The force acted at an angle alpha to the horizontal where tan alpha 4 by 3. So that's given tan alpha 4 by 3 means, if I consider right angle triangle, this is alpha tan 4 by 3. So this will be 5. We can find sine, cos, anything now. Tan alpha 4 by 3. Right, okay, that's given. So we can find sine or cos alpha, anything what we want now. Right, okay. The coefficient of friction between the particle and the contact surface. So I told that depends on the property of the contact surface that remain constant. So that is mu is equal to 1 by 4. Given that the particle does not move, it's at rest. So if it at rest means the force which is trying to pull the particle on the horizontal flow must be less than the limiting friction. That's all, right? Show that P less than 5W over 8. So we have to show that. So this is the thing we have to show. We have to show that P less than or equal to 5W over 8. So this is the condition we have to show when the object is at rest. Okay, so I already told that, explain. So if the object wants to be at rest, the force that is used to drag or pull the object on the surface must be less than the limiting friction. Okay, I'll draw the forces acting on the particle again separately. So if I draw the free body force diagram, in physics we call free body force diagram. So what are the forces that? Its weight is acting W downwards. The contact force normal reaction is acting this way. It's going to vary here because part P is acting this way. The force P is acting this direction. This way there is a force P is acting at an angle alpha. Okay, when you think about this force P, it will have a horizontal component. P cos alpha will act towards right. P sin alpha will act downwards. So the particle has intention of moving towards right because P cos alpha will act towards right. So the friction will act to the left. So the friction will act to the left. The friction force Fr will act to the left. So the condition, the force which is trying to pull the object on the horizontal flow is P cos alpha. So if I want, I can draw again the diagram. So if I draw the force again acting on the object, so the weight is downwards. P resolve it horizontally. P cos alpha this direction. P cos alpha acting this direction. P sin alpha, the component of it acting vertically downward. P sin alpha acting this direction. Also the normal reaction between the two contact surfaces, they are acting vertically upwards. I'll use green color force for that normal reaction. Acting upwards, the contact surface, and the friction is acting to the left. These are the two forces. So the condition here, P cos alpha, that's the only force trying to pull the object on the horizontal surface. That P cos alpha must be smaller than maximum friction. What could be the maximum friction? Maximum friction is the limiting friction. Then the object will be at rest. Maximum friction is given by mu times normal contact force, mu times R. But R depends on P sin alpha, because you can see there's a component of P on vertical direction. So P is going to decide the R. I already explained all those theories. Okay, we'll find those things now. So since it's at rest, we can say we consider vertical direction. It's at rest in vertical direction. So r minus p sine alpha minus w equal to 0. So r is equal to w plus p sine alpha. Sine alpha, if you consider here, sine alpha is equal to 4 by 5. So that is w plus sine alpha 4 over 5. So 4p over 5, that is r. Okay, so if the object wants to be at rest, the force that is used to drag or pull the object on the surface must be less than the limiting friction. Limiting friction is the maximum friction, which is given by mu times r. Okay, so the force that is trying to pull the object on the horizontal surface is P cos alpha. So P cos alpha must be less than or equal, we can say equal also, less than or equal to the limiting friction Fr max. The limiting friction is mu times r. So but Fr max is equal to mu r. Okay, so we'll continue. So P cos alpha must be less than or equal to mu times r. That's all. We'll continue. Now P cos alpha is equal to 3 by 5. So cos alpha 3 by 5. So that is 3p by 5 should be less than or equal to mu r. R we have something. Mu means mu is 1/4. 1/4 into r, that is w plus 4p over 5. That's all. Solve it. You'll get the condition what they asked to show here. Okay, so I'll write it there. Okay, we'll continue that. So that means we can solve this further. Okay, so if I take 5 inside the bracket as LCM, so it will be 5w plus 4p. This 5 and this 5 will get cancelled later. 3p over 5 less than or equal to 1/4 of 5w plus 4p over 5. 5 get cancelled, cross multiply. 12p less than or equal to 5w plus 4p. 4p bring it to the left. 8p less than or equal to 5w. So p should be less than or equal to 5w over 8. So if this condition is satisfied, it will be at rest. P less than 5w over 8. Okay, I hope you understood that. Okay, question number 7. It's based on Newton's second law, F equal ma. A car of mass 1200 kilogram is towing a trailer of mass 600. So this is 1200, this is 600 kilogram. Up a straight road as shown in figure 4. The road is inclined at an angle of alpha. We are at sine alpha 1 over 12. So they are saying sine alpha 1 over 12. So that means when you consider a triangle, something like right angle triangle, sine alpha, this is 1 over 12. So that means, yeah, that's, we'll see, right? Okay. Sine alpha 1 over 12. The driving force produced by the engine of the car is 3000 Newton. So that's the driving force given by the engine. So normally it's a contact force, the tire, the contact force provides, but anyway you don't need that. We'll accept it as just 3000 Newton, this direction, 3000 Newton. That's a driving force. The car moves with acceleration of 0.75 meter per second squared. The non-gravitational resistance to motion of non-gravitational resistance means the component of the weight also a resistance, but not that one. That is the actually a gravitational resistance due to the gravitational force, but they are saying non-gravitational resistance. So for example, if you keep an object on an inclined surface, if this is angle alpha, the weight will act vertically down. I already used that in the previous example also. So if the weight is acting vertically down, this is 90 degree, this is 90 minus alpha. If you think about the normal contact line, this is 90 degree. So this is alpha, the dotted line, and the slope 90 degree. This is 90 minus alpha because this is 90. So in this right triangle, this is 90 minus alpha. So this is going to be alpha. So the component of the weight, this is mg, the component of the weight, this is mg. So the component of the weight along the plane down, that means if I resolve this weight along the plane down, means perpendicular to this dotted line, that is alpha, that makes an angle alpha here, that is going to be mg sine alpha, mg sine alpha. So if the object is moving upward direction, this mg sine alpha is opposite to the motion, opposite to the motion. If the object is moving this way, the component of the weight along the slope down mg sine alpha, that is an opposing force we call gravitational resistive force. Other than that, there could be friction. So here they are saying non-gravitational resistance of the motion of car is modeled as a constant 2R. So on the car, the non-gravitational resistance means it's like a friction drag for like that is 2R. The trailer, that is R. For the trailer, the resistive force, non-gravitational means it's mostly a friction, that is R. Okay. The car and the trailer are modeled as particles. The tow bar between the car and the trailer is modeled as light rod, that is parallel to the direction of motion. So that means the tension will be the same at all points. If we take that is a light rod, say for example, two objects are connected by a rod. Imagine there is a car, just I draw it on a horizontal road. There is a bar, a rod which is connecting another one. So there, why we say it as a light rod means the tension will be the same at all points. Say for example, the mass of this one is m1, mass of this one is m2. Both are moving at the same acceleration, means if I think about the free body force diagrams, the forces acting on it, you are pulling this with a force F. So the force F is acting here. So this will pull this one by using the rod, means there will be a rod, there will be a tension T1 here. According to Newton's third law, there will be the same tension T1 here. The rod will pull the second trolley M2 with a tension T2. Here will be T2. Because T1, T2 will be different if this has a mass. But if it is lighter, we consider the rod now. The rod also accelerating. When the trolleys are accelerating, the rod also accelerating. So for the rod, if I use F equal ma, T1 minus T2 equal to ma. If it has a mass. But if I say m equals 0, that's the reason in your syllabus they say light rod. M equals 0 means T1 minus T2 equal to 0, then T1 equal to T2. That means the tensions will be the same at all points of the rod. Okay, so the tension of the third law pair of the tension exerted to this trolley and the tension exerted by the rod to this trolley, both will be the same since the rod has no mass. If we take the rod has a significant mass or considerable mass, then the tension will be different. But in your syllabus, we take the tension is same. To take the tension is same, we take the rod as a light rod. That's the reason they always, you can see all questions, they say light rod. Okay, so light rod that is parallel to the direction of motion. Using the model, show that the value of R is 60. Okay, so these are the forces acting on it, on the object. So on the car and the trailer, they have the forces acting. So we can use F equal ma for the whole system we normally write. Anyway, but it's not an issue because they're asking about the force R acting on it. So the acceleration is given 0.75. We can say for the system, because when we consider system means we don't consider the tensions acting on the rod. So if I use for the system, along this direction, I'm going to use F equal ma. So this is 3000 minus its component of weight along the slope down, that is mg sine alpha. So the mass of that is 1200 kilogram. So that is 1200 into, I'll write first okay, m1g sine alpha minus 2r, 3000 acting up. So I'm taking F equal ma upward direction, 3000, not 300, 3000. The component of the weight along the slope down, m1g sine alpha minus 2r. That is for this one. For this one, minus m2g sine alpha, the component of this weight along the slope down, minus r, equal to ma, the total mass, that is m1 plus m2. I'm writing for the system. Anyway, no problem. If you want, you can write separately for this one, this one. So then you have to solve both. We take two equations, and when you add it, you will get the same equation. Okay, so continue. This is 3000 minus m1. m1 is the mass of the car, which is 1200 into 9.8 sine alpha 1/12 minus 2r minus r, so minus 3r, minus, I would have add both together, this m1 plus m2, doesn't matter, I am doing separately. So m2 is 600 into 9.8 into 1/12 equal to m1 plus m2, 1200 plus 600, 1800, into acceleration is given 0.75. Okay, solve it. Everything you know, all numbers you know, only r we don't know. Find the value of r. So solve it, you'll get the answer. So you'll get this, if you solve or take r to the right and bring this to the left, so you'll get 180 is equal to 3r. R is equal to 60. Okay, second part, find the tension in the tow bar. Okay, so this is the tow bar. The tension on this one will be this direction. Tension will be this direction T. Here this will have the tension this direction. Same tension I told, because the tow bar has no mass. Okay, so now I can use F equal ma either for this or this. Anything I can use F equal ma. Only one unknown T. So second B part, this is A part, B done. Now the B part, we use F equal ma for the, I can use it for one of it, for the trailer. So for the trailer, I will use F equal ma along the plane up at an angle alpha. So I want to use F equal ma along the plane up, okay, at an angle alpha. So what are the forces? T minus R minus m2g sine alpha is equal to m2a. Is it? T, when I consider only the trailer, the force acting on the trailer which is pulling upward is the tension provided by the tow bar, is giving the required force to accelerate the trailer. So that is T. T minus m2g, the component of the weight along the slope down, m2g sine alpha, the r is down, minus r equal m2a. So we know everything. Substitute that T minus 60 minus 600 into 9.81 sine alpha 1/12 equal 600 into 0.75. Solve it and get the T. Okay, so T is equal to 1000 Newton. C part, when the car and the trailer are moving at a speed of 12 meter per second, the tow bar breaks. So if the tow bar breaks, tension will become zero. So this part is not there. The tow bar breaks, so they are becoming two separate objects. So it become two separate objects. So the forces acting on it are, given that the non-gravitational resistance, that is capital R, that's the resistor force acting, non-gravitational resistance acting on the trailer remaining the same, use the model to find the further distance moved by the trailer before it first comes to rest. So that means it's like this. When the tow bar breaks, no further tension on it. So this is the trailer. So the resistive force still acting on it, same as earlier, that is capital R, the resistive force. We found the value, that is earlier we found it 60 Newton. The compound of the weight also acting downwards, that is mg sine alpha. The speed at that moment when it breaks is 12 meter per second. So what will happen? It will decelerate because the motion is along this direction. The motion is along the slope upwards. At the moment it breaks, the tow bar, 12 meter per second. But the forces, how many forces are opposing the motion? One is the component of the weight along the slope down. Mg sine alpha is opposing the motion. R, the non-gravitational resistive force, also opposing the motion. There are two forces opposing the motion. So whenever there is a opposing motion on a moving object, that means whenever there is a force opposite to the direction of motion, the object will decelerate. So when it decelerates, finally the speed will become zero. The question, what's the distance moved by the trailer when the speed becomes zero from the moment the speed was 12 meter per second? Okay, we need to find the deceleration. So along the plane up, if I use F equal ma, because it's moving upward along the plane, so that's the reason I'm using F equal ma along the plane upward direction. There are two forces acting, those are opposite to the direction of motion. So certainly I know those forces are opposing the motion, it's going to decelerate. So the first force is the compound of the weight downwards, that is earlier I used m2 for the mass of the trailer, still I'm using m2g sine alpha, that is downwards, so minus. Also R is downwards minus. Motion is upwards, so that's the reason I'm using this equation along the direction of velocity. So these two forces opposite, we are getting minus minus equal to m2a. Right, that is minus 600 into 9.8 sine alpha 1 over 12 minus 60 equal 600a. Find the a, you will get negative answer because along the direction of motion a is negative, means negative sign shows opposite to the direction of motion is the acceleration. Opposite to the direction of motion is the acceleration, means deceleration. So when you find the a, you will get minus 11 over 12 meter per second square. Okay, so we know that it's going to decelerate. The question is, find the maximum distance it moved along the plane up. So along the plane up, we'll use v squared equal u squared plus 2as. Finally, the speed becomes zero. Initially, at the moment it breaks the tow bar, it was 12 meter per second. 12 squared plus 2 into, the acceleration is negative, 11 over 12 s. Okay, solve this one. You'll get 22 s over 12 is equal to 12 square, that is 144. Find the s. You will get s is equal to 78.6 meters. So it will move a distance 78.55 or 78.6 meters from the moment the tow bar breaks until the speed becomes zero. Okay, question 8. This diagram is given, it's on vectors. A square floor space ABCD with center O is modeled as a flat horizontal surface measuring 50 meter by 50 meter as shown in figure 5. The horizontal unit vectors I and J are in the direction of AB, that is A to B, that is positive I, A to D, that is positive j. So that means this way minus I, this way minus j. All all position vectors are given relative to O. So O is the origin. So I can imagine a coordinate, the axis like this way. So I can imagine a coordinate axis like this. So this is the origin, O is the origin. So that means this is I, this is j. This length is 25, means this is going to be minus 25. This is going to be plus 25. Anyway, right. So at time t equals 0, a small robot R is programmed to travel across the floor at constant velocity. Constant velocity means the magnitude remains constant, direction also remains constant. Constant velocity, if they say constant speed, then the magnitude remains constant, the direction could change. But constant velocity means both magnitude and direction remain constant, remain unchanged. At time t equals 0, R is at the point where the position vector minus 2i plus j meter, minus 2i plus j meter is the position of R when t equals 0. Minus 2i means we know that minus I is downwards, so downward direction 2 units. Minus 2i to the left, from here this is the O, minus 2i to the left is minus from origin, they are taking towards right is positive unit vector I. So minus I means to the left 2 units, plus j upward direction 1 unit. Somewhere here it would have stayed, anyway we don't need, that is here 2, this is 1, okay, somewhere it was here. At time t equal 11 second, R is at the point with position vector 9i plus 23j, 9i. So on the right side 9 units and upwards direction 23. Somewhere here it would have come. This is 9i, this is 9i plus 23j, this is 23. So it was initially somewhere here. Now it has come to this position. It's moving at constant velocity. So the direction of motion is from this point to this point. So this could be the direction of motion. It would have moved from here to here. At constant velocity means no change in direction. So it's going to continue its motion along that line. So the question is, at time t seconds, the position vector of R is R meters. Find in terms of t, I and j an expression for R. Okay, so if I draw the diagram again, so initially it was here. Finally it is here. This is the origin O. So this position, if I call P, if I call this position Q, OP is given as, that is OP, the vector OP is given as minus 2i plus j, minus 2i plus j meters. Then OQ is given as, OQ vector is given as 9i plus 23j, 9i plus 23j. This is A part. So the displacement vector is along this line. I used trailing there, so here also I use. This is the displacement vector. PQ is the displacement vector. This is the displacement vector is PQ. So this is initially when t equals 0, it was at P. When t equals 0, it was at this position when t equals 11 seconds. Okay, so the question is find in terms of t, I and j for the position vector R. So it is at position vector R. So the position vector here somewhere we need to find OR. Okay, this is a very common question. OR. R is the position vector in terms of time t. At time t, it's at point R, right? So if you want to find that, first we need to find, it's a constant velocity. We should find the velocity vector, right? So at time t, the displacement, if I know the velocity vector and constant velocity, so the displacement during time t is equal to time into velocity vector. Remember that the displacement vector is given by time into velocity vector gives the displacement vector. So the position vector we can find initial position, this we need to find OR. OR is equal to OP plus PR. PR is the displacement vector. Okay, to find the velocity vector, we need to first find the displacement vector during 11 seconds. So this is when t equals 0, this is when t equals 11 seconds. So the displacement vector that is given by that, if I can say the displacement vector S is going to be the displacement vector that is going to be PQ. PQ is equal to PO plus OQ, PO plus OQ, PO plus OQ. What is PO? PO is equal to minus OP. This is minus OP, that's all vectors, minus OP plus OQ. PQ is equal to PO plus OQ, but PO is equal to minus OP. When you invert the vector, it will become minus sign. Minus OP. OP is 2i plus j. So minus 2i plus j plus OQ, that is 9i plus 23j. So it's going to be 11i plus 22i. That's the displacement vector PQ. Displacement vector PQ is 11i plus 22i. So velocity vector. What is velocity vector? Displacement vector divided by time. So 11i plus 22 j over the time taken to move from P to Q is 11 seconds. That is going to be I plus 22j. That is the velocity vector. I plus 2j is the velocity vector. Okay. Now the question is, since we know the velocity vector, the question is, we need to find the position vector r at time t. So the position vector r at time t is given by r is equal to, remember this method, r is equal to the position vector at particular time r is equal to, that is at point r is equal to OP plus PR, that is OP plus PR. So OP, we know that is the initial position vector. Initial position vector is minus 2i plus j. PR, how to find? Velocity vector into time. That is velocity vector into time. Velocity vector we found it. So minus 2i plus j. Velocity vector I plus 2j into t. Solve it. You will get the position vector at any time t. So that's going to be minus 2 plus p I, or you can say t minus 2 the other way, t minus 2i plus 2 plus 2t plus 1. That is the position vector. We'll check it whether the position vector what we got is correct. When t equals 0, it was at P, the position vector was 2 minus 2i plus j. Substitute t equals 0. Substitute t equals 0. You will get this 0 means minus 2i. This becomes 0 plus j. Minus 2i plus j, we are getting correct. We will see whether the position vector is correct by substituting 11 seconds. Are we getting the position vector q, that is 9i plus 23. Substitute 11. 11 minus 2 is 9i. 9i. 11 into 2, 22 plus 1, 23j. Correct. So what we got is the correct answer. You can check it like that. Okay, now question number 8, B part. So it says that a second robot S is at the point C. At time t equals 0, S leaves C and moves with a velocity, constant velocity, minus I minus j meter per second. At time t seconds, the position vector of S is simple S vector. They are giving it. Write down in terms of t, I and j an expression for the position vector of robot S at time t. Okay, so how do we find? To find the position vector at a particular instant, we should know the position vector at initial time t equals 0. That position vector initial plus velocity into time, right? So we know the initial position vector of the robot S, we know that. So the initial position vector of robot S, let it be S bar, S dash, so OS1, the vector, initially it was at C, or we'll see OC, because it was at C, they are saying OC. Perfectly, we can use OC because it was at C, they are saying. So the coordinate of OC is equal to, in I direction 25 units, because this DC is 50, O is the center, means this length from O to this point C in horizontal I direction is 25, because this is 50, half of it. So that's going to be 25I plus C in J direction. This is 50. O is center, means this is 25. So 25J. The velocity vector of S also given. The velocity vector of S is a constant velocity, they are saying, minus I minus J meter per second. This is, I can say, meter. Earlier we found the velocity vector because earlier they gave the two positions in 11 seconds interval. Initial position vector given for the robot R, final position vector given at 11 seconds. So we found the displacement vector and divide by the time, we will get the velocity vector. Okay, that is for the earlier robot R. Here the velocity vector is directly given. Okay, so the position vector of S is given by, that is OS at time t. OS is going to be position vector, that is initial position vector OC plus the velocity vector of S into t. That's all. So OC is 25I plus 25J plus the velocity vector minus I minus J times T. Solve it, you will get 25 minus Ti plus 25 minus Tj. That is OS at time T. That is the position vector OS or vector S. OS we can name it vector S. So that is going to be the vector S at time t. So that is, yes, 25 minus Ti, 25 minus Tj. Okay, so now the C part, they are asking to find, show that SR. So we found the OR, position vector of robot R at time t. We already found it in the first part, is it? We found it in the first part, the position vector of robot R at time t, that I wrote it here, t minus 2i plus 2t plus j. We found it in the first part. Now this is position vector R, means that is OR, vector OR. Is it from O? The position vector of OR is denoted as R, OS denoted as S. Now they are asking to find C part SR. They ask you to find the vector SR. So find the vector SR means SR is equal to SO, vector SO plus OR. Vector SR is equal to SO because all are related to O. O is the origin. SO plus OR. Because SO is negative OS minus OS plus OR. So minus OS, how to find the minus OS? Minus OS means we have to take minus of it, that is T minus 25I plus t minus 25 j, because I'm taking minus multiply is t minus 25 j plus or that is t minus 2i t minus 2i 2t plus 1j. Solve it, you will get the expression what they asked to give. So here I, if you say t minus 25, t minus 2 means 2t minus 27i plus t minus 25j, 2t plus 1j means, so 2t plus t, 3t minus 25 plus 1, so minus 24. That's the thing they asked to show, that 3t minus 24 j meters. Yeah, this is in meters. We can give the unit meter. Okay. Okay, so the last part, find the time when the distance between R and S is minimum. So we know the vector SR, that depends on time. Okay, different time we'll get different vectors. The position vector of R related to position vector of S it's going to change. Okay, so if we want to find the minimum distance, they are asking. Minimum distance means we need to find the modulus of this vector. We'll get it in terms of time. So the modulus vector gives the length of vector SR. So S is the SR means the position OS plus OR. So the modulus of this SR will give the distance between S and R in terms of time. So when the time changes, the distance is going to change. Anyway, to find the distance between S and R, whether it's a minimum or whatever it is, first we need to find the modulus of vector SR. So you know how to find the modulus of a vector. If the vector is AI plus BJ, so if this is a vector, say for example vector P, so the modulus vector P is equal to square root of A squared plus B squared. Okay, so we need to find the square root of this square plus this square. We'll get it in terms of time and we'll continue to find the shortest distance. Okay, so we'll find the modulus of SR, that is the distance between S and R. So modulus of SR is equal to square root of this squared, that is 2t minus 27 squared plus 3t minus 24 holding squared. So that modulus of SR gives the distance between S and R. Let it be x, we'll put it as x. That is going to be to the power half, we can put square root, that is 4t squared minus 2 into 2t into 27, that will be 108t minus 180 plus 27 squared 729 plus 90 squared minus 2 into 24 into 3t, that is 144 t plus 24 squared is 576 to the power of half square root. So it's going to be 13t squared, yeah, 13t squared, 4t squared, 90, yeah, 13t squared minus 252t, 144t, 180, yeah, 252t plus 1305 to the power of half. That is the distance between S and R in terms of time. So when the time changes, the distance is going to change. So they asked to find the minimum distance. You know, it's a function, the distance is a function of time, t, and we need to find the minimum means, you know, the differentiation must be equal to 0. dx over dt must be equal to 0 to find the minimum maximum, you know that. If there's a function, to find the minimum value, we have to differentiate equal to 0. So we'll differentiate it. Dx over dt is equal to 13t squared minus 252t plus 1305 to the power, half comes here when you differentiate, sorry, there's half, then become minus half, the square root, half minus, the power minus 1, so half minus 1 is minus half, and differentiate inside the function, that is going to be 26t minus 252 equal to 0. When you differentiate, it will be 0, I don't put it, equal to 0 when x is minimum. When x is minimum, the shortest distance, the differentiation must be equal to 0. Okay, so if this wants to be 0, this will become denominator. Minus half means it will become denominator of this one. This is minus half, so this will become denominator of this one. So this can't, we don't need to analyze this one because this is the denominator. So this is the numerator, this must be equal to 0. So hence I can say 26t minus 252 must be equal to 0. So 26t equal to 252. Find the t. So you will get t is equal to 9.69 seconds. The question is, find the time. Okay, they are not asking to find the minimum distance. Time, that is time is equal to 9.69 seconds. Okay, that's the answer. They are asking to find the time. They are not asking to find the shortest distance. If you want to find the shortest distance, substitute this time in this function, you will get the shortest distance. But they are not asking about shortest distance, they are asking to find the time. Yeah, that's the question is, find the time when the distance become between r and s is minimum. So we found the time, 9.69 seconds. If they ask to find the shortest distance, substitute this time in this equation. Here x is in terms of time function. Substitute there, you will get the shortest distance, but they are not asking it. So that's the end of the discussion of this paper.